We are going to talk about small modular nuclear reactor. In short, we call it SMR. And why it is important for prelim of 2026? There are 5 reasons behind this. First reason is very definitely that the UPSC loves energy technology related question. In the last 5 years, if you see, the UPSC has asked 9 questions from energy sector itself. Very recent current context is that recently President Putin was visiting India, and during his visit, he made an offer to India that Russia is willing to collaborate with India in the field of nuclear small modular reactor. So then again, it was in news some time back. Then in this topic, there is a healthy amount of technical terms, technical concept that can be important. Plus, there have been some recent policy initiative that is again important. UPSC generally keeps an eye for such emerging concepts and would like to explore the candidate's knowledge and understanding on those topics. That way, it is important. Besides, what is very remarkable that in this field, India is trying to develop its own reactors. And the Bhabha Atomic Research Center is already working at it. So anything that is cutting edge and that is kind of indigenously being developed, that catches UPSC's attention. And last but not the least, in the recent budget 2025-26, the government of India has announced something called Nuclear Energy Mission, and at a sizable budgetary allocation, 20,000 crores. So all of that, okay? At the end of the day, what kind of questions could be asked to you? So I'm just giving you a glimpse of question, but please skip these questions right now. Towards the end of this presentation, these questions will come back again. And after watching this, you should be attempting those questions, okay? But these are illustrative questions, the kind of question the UPSC can frame for you. And once you have gone through this, you will be able to handle that also. So first and foremost, let's ask ourselves, what are small modular reactors? So they are a kind of nuclear reactor. And basically, their reactor technology is pretty much something that applies to the conventional reactor. It can be pressurized water reactor, it can be pressurized heavy water reactor, so those kind of reactor. But what makes it small modular? So you will have to break these two terms, small. So small in capacity. It is a smaller in size also, but main thing is a small in capacity. So these reactors in their capacity, they are of 300 megawatt electricity or less in their capacity. So that makes them small. And of course, they are size-wise also, they are small. And second, modular. So to understand modular, you will have to understand how modern day reactors are built. So modern day conventional reactors are built at a site where they are supposed to work. So suppose we are setting up a nuclear reactor in Kudankulam. A lot of people will pronounce it as Kundankulam. So I always ask these people to go and check the spelling carefully. Where is N after the first U? There is none. So it is Kudankulam in Tamil Nadu, and where we have already started working with 2 reactors. They are functional, and 2 more reactors will be commissioned soon. And another 2 reactors are in the pipeline, and that is being built with Russia. But the point here is, so that is pressurized water reactor. So a small modular reactor can be based on pressurized water. It can be based on boiling water. It can be based on pressurized heavy water, on which most of our reactors are based. It is based on those. But the thing is that the entire reactor can be built elsewhere, and then it can be transported to the site of installation, pretty much like machinery of any heavy industry. Like a machinery of heavy industry will be made at a bigger plant, and then this machinery will be sent by railways, by road transport, and then it will be installed. That makes it modular. So what happens that suppose you want to set up a 3 gigawatt plant, all that you need is 10 such SMR, imagining that each one will have a capacity of 300 megawatt. And it is likely that you just need 300 megawatt because it is a remote Himalayan village or a set of villages where 300 megawatt will be enough. You just need one. So there is modularity. You can keep adding the modules and its capacity will be increasing. So small modular. So here it is a fission reactor. Yes, that part is important, that it is a fission reactor. Fusion reactor is anyway not a reality as of now. Commercially, there is no fusion reactor that is working anywhere in the world. In that, the global community is collaborating at ITER, that is in southern France, Cadarache. So that is nowhere deployed. So of course, it has to be a fission reactor up to 300 megawatt electric output. And then it is designed for factory manufacturing, modular transport, and then on-site installation. So it is physically smaller. It is factory mass produced. In a factory, it will be mass produced and then it will be transported. That's what. Another very interesting feature is that they have got passive defense or passive safety systems. So if anything fails, it does not really require any safety system to be switched on. There are passive systems which will automatically get triggered if anything goes wrong. So you do not need manual intervention. You do not need external power or anything like that. So that in a way, no power required, no intervention needed. So that in a way makes them pretty safer than the comparable traditional reactor. So that is second. And third is that they are scalable and they can be incrementally developed. Means you need a small output, you need just one. You need more output, you bring more modules, and you have a bigger output per plant. And finally, they do not need so much of water for cooling. They do not need so much of land as a traditional power plant, and as a result you can set it up anywhere. So there is siting flexibility, means you need no special site to set it up. Like in our country, majority, I'm not saying all, but majority of the nuclear power plants and elsewhere in the world also are close to the coastal area, so that the hot water could be easily discharged in the sea. But here you don't have such requirement. It has reduced water needs because there is lower cooling water requirement. It has a smaller land flexibility, land footprint. Then cooling water ki baat humne kar li, and that gives it more deployment options. For example, Indian Railway is in touch with Department of Atomic Energy to set up these plants where the energy generated by these plants will be solely used by Indian Railways. On a side note, remember, Indian Railway is following a target to decarbonize the railway transport in India by 2030. And there it is looking at SMR as an attractive proposition where railway will be making land available, and then the government will be the Department of Atomic Energy through Nuclear Power Corporation India Limited. It will be setting up the power plant, and then those power plants will be producing electricity for the railway. So you can imagine, similarly, the government has relaxed certain laws so that big industries, especially in the metallurgical sector, they can set up nuclear SMR for their captive use, like Tata Steel in Jamshedpur. So right now they mostly burn coal for their metallurgical purposes, but in future, who knows, they can be using nuclear power, and that captive plant will be meant solely for utilization of power by this particular industry. So on. Okay. So now I hope you have gotten a sense of what is a small modular reactor. Now, what are the benefits? What are the strategic advantages? First and foremost, climatic and environmental benefits. It is at the end of the day a cleaner source, and then it also does not have too much demand of land, too much demand of water. So that is one. Then there is operational flexibility. Either you can run this kind of plant at its full capacity, the base load capacity, or load following mode, means as much the need is, it is at that capacity level, you will be running that. So that flexibility makes it the right source of electricity to supplement the solar and wind sector, because solar and wind sector are somehow dependent on the time of the year, the season, and wherever the output falls, this can ramp up and this can fill the gap. Then of course, to set it up, you do not have massive upfront cost compared to the large plant, so you can set it up pretty much anywhere, and a lot of like entities can also come forward and set it up. It is affordable and financeable because there is modular investment. You start a small, then you keep adding the capacity, and that is perfectly fine. Its construction period is short, and also because of enhanced passive safety measures, its safety profile is better. That way, wherever you are setting it up, the general local resistance is likely to be less. Then reduced environmental footprint, we have spoken about, reduced land requirement, reduced water requirement, and repurposing of existing infrastructure. Suppose like in Delhi, within the boundaries of the city, coal power plants have been shut down. Now, whole lot of land is available for those coal power plants. the building is available. Can we use that building, that land to set up a nuclear power plant, and that too SMR? Answer is yes. And this is called setting up brownfield project. Greenfield is where nothing exists, and brownfield where something existed, it no longer exists, and you use that land. Okay, so it can very well be used for brownfield site, and that is something which is a very good prospect. Now we move what all we are doing in our country. So first and foremost, what is the context? Why we are even considering this? One is our energy demand is growing, rapidly growing energy demand. Second, we are looking for ways to decarbonize our economy. So that is second one. And by 2070, we have already committed at the Glasgow summit that we will be achieving net zero. So we have to be working in that direction. And we have to enhance our energy security, because we cannot forever rely on coal. We cannot forever rely on imported petroleum products. So we have to find our own solutions. To that end, Government of India announced nuclear energy mission in the union budget of 25-26. The outlay is 20,000 crore, and it is largely revolving around SMR. So the idea is to augment research here, development here, and deployment. And the immediate target is that by the year 2033, in our country, five indigenously designed and operational SMR have to be installed. So what we have got is approximately 8 years. It is end of 2025. So approximately 8 years. And in these 8 years, India has to build its own, design its own, and install its own SMR 5. And that will just be the beginning. Okay. And within our country, the Bhabha Atomic Research Center, BARC, is responsible for designing it, developing it, and validating the indigenous technology. So that's what we are doing. And then, for the first time ever in the nuclear power sector, we are looking for ways to increase the participation of the private sector. So for that, we have already amended two different laws in our country. So the first law that has been amended is Atomic Energy Act 1962, and second is CLINDA. CLINDA is Civil Liability for Nuclear Damages Act 2010. So it basically sets the liability on the part of the companies which run the nuclear power plant in such cases when there is a nuclear accident. So CLINDA has been amended, Nuclear Energy Act, Atomic Energy Act 1962 has been amended to allow private participation. What kind of private participation right now we are looking at? So we are basically looking at private firms to finance these projects. So private firms will be coming forward, they will be financing these projects, and then they will be receiving the ownership of the electricity generated. But very important fine point, that the nuclear plant, even though it has been financed by a private business house, think of Tata's, think of Ambani's or Adani Group, and they all are among the applicants, because they all are having some footprint in metallurgical industry, which needs a lot of power. So they will be financing it, but they will be having a right over the electricity produced. The power plant will be owned by Nuclear Power Corporation of India Limited. NPCIL will be owning it. NPCIL will also be operating it. These private entities will not be allowed to own or operate for obvious safety and strategic reason. And this electricity will be used for captive consumption by steel industry, aluminum industry, and other energy intensive sectors. So I hope until now everything is clear, right? And NPCIL, Nuclear Power Corporation of India Limited, it retains the ownership and it maintains the operational control. And we have already done legislative amendment. Can you see this slide alone is a minefield of questions? And finally, and I've kept it crisp only, we are already developing some indigenous reactors in this field. So first one is BSMR, Bharat, a small modular reactor. Its capacity is 200 megawatt, therefore we call it BSMR 200, and it is pressurized water reactor. It is the same pressurized water reactor technology that is being used in Kudankulam plant through a traditional setup. At Kudankulam, just to be clear, that is not a small modular reactor, that is a conventional huge reactor, 1 gigawatt capacity per reactor. So that is what it is. Here the capacity will be 200 megawatt, and it uses what? Slightly enriched uranium. You have to remember these tiny details. And why this reactor is being developed? This reactor is being developed for remote locations and a stable base load generation, like full capacity generation, and also for complementing the renewable energy. Then there is another one that is called Bharat Small Reactor with slightly more capacity, BSR 220. So its capacity will be 220 megawatt, and its technology is pressurized heavy water. The same technology that is powering 20 out of 24 operational reactors in our country. So India has perfected this kind of reactor technology, and it is based on that. So it will be using uranium 235 plus uranium 238 mixture, and its idea is that it will be using it will be giving power to industries which are developing this as a captive facility, right? And then a small modular reactor 55, very small, 55 megawatt. It is compact light water reactor, and for smaller applications, distributed power needs in remote areas and all that. And then there is something called high temperature gas cooled reactor, HTGR, just 5 megawatt, and it is like its purpose is to produce heat for the industrial purposes, and it is going to be used in hydrogen production, right? And finally, Indian Railway wants net zero carbon emission by 2030, something that I was telling you, and its electricity requirement is going to be 10 gigawatt by 2030. And here Indian Railway is collaborating with Department of Atomic Energy and Ministry of Power, so that Indian Railway can provide land. It can offer long-term power purchase assurance that if you generate, we will be buying that power. And then Ministry of Power and Department of Atomic Energy will be establishing these plants and will be ensuring that nuclear fuel is being supplied. Okay, so that's how the indigenous reactors are being developed. And here are your questions. And Russia has already offered us for collaborating in this field, and India has to take a call. And Russia has made a very interesting offer of floating a small modular reactor, because Russia is already operating one. Like, so Russia has offered that also. So that is all. And look at these questions. And if you have heard me well, if you have been carefully following this question, and then this question, and then this question should be within your reach. So that's all right now.